On this video today, we're going to talk about three-way points and how to switch their frogs using our system. A customer called me last week expressing concern that he couldn't quite understand this or get it right. So I looked into it and I thought it would be a good opportunity to produce a video that I could share with him and everybody else. For the demonstration, I'll be using Peco SL199E code 75 three-way turnouts. Now, first thing you should note is it says here, this turnout requires single pole changeover switches not included, and it gives an example of the PL13. And that's great because we happen to have single pole switches on our relays, and you can use a relay driver. In this case, it's switching a bank of 12, or you can use the integrated relay driver in the Servo 4R to drive up to 4 servos and 4 corresponding relays. So these will form the basis of today's demonstration. Now, I suggest everybody follow the manufacturer's guidelines, and in the case of Peco, they're on the back. And what this tells me is two things. One, there are only 2 frog wires, so it only needs 2 switches, and that 2 of them are wired together. So the one at the top is wired on its own to this tie bar, and these 2 are wired together to the second tie bar. So what I've done on this MDF is I've labelled the frogs, frog 1, frog 2 and frog 3 wires, and the frog 2 and 3 have been joined together. And then I've also labelled tie bar 1 and tie bar 2. And in preparation, I've hooked up the servo controller so I can move tie bar 1 with channel number 1, servo number 1, and tie bar 2 with servo number 2. So, to help, I've created this crib sheet which will be added to the Servo 4R and the relay guide, module user guides. And I've added a few instructions here just to remind you. So it's really simple. I've numbered the frogs, I've numbered the tie bars, and I've provided a wiring example. And I say example because it'll be different for you in certain ways, and I'll show you how to figure out in which ways they're different and in which ways they're the same. So step 1, determine which relay channels will be used by operating several times and noting which LEDs on the relay board operate. So if I want to know for tie bar 1 which relay I should wire up, and I have 4, and it could be any, just depends, operate the switch, and can you see there's a light coming on here? I can hear the relay clicking as well. So for tie bar 1, I'm going to use the relay marked IN1, this guy. If I'd wired this up using a Servo 12, again, it could be any relay at all. So I need to know how to identify that relay. If I bring on a Servo 12 and I power up the relay module, I'll join the 2 using the connecting lead. 1 to 2. So assume that number 7 was operating my points. You can see here which relay that refers to because the light is going on and off. If I move all the switches down, turn them off, might be easier to see. All the relay lights are off. As I operate number 7, it's this one. There it is. So I can see from the 4 lights here which relay to wire to that frog. If I'm doing another one, number 11, this is the relay, because the light is flicking on and off, I've identified to wire up to the frog. Don't skip that step, because I have seen some people wire up frogs to the relays and not check which one is which, and when they flick frog 3 or points 3, relay 7 goes off and they wonder why, and it's because they skip that step. Flick the switch, determine which one it is. For this one, it's here. If you're doing number 1, it's that one. If you're doing number 5, it's that one. So we've determined that it's frog number 1, or the bottom one here. And these are the terminals on the frog. So let's wire up our frog. I'm going to wire the frog 1 to the relay 1 that's driving tie bar 1. Check it again. Tie bar is moving and frog is switching on and off. So I know it's this relay. No guesswork at all. So let's power off, and what I'll do, hopefully you'll be able to see that there, is take a wire. I'll just strip it off and stick it into the terminal. I better slack them off first. Where's my screwdriver? Give me a screwdriver. There we go. Undo that. Undo that. Undo that. I may as well do the second one as well, as we'll be using it. So I'm going to stick this one into where I have the green wire in the centre, which is the frog. In my case it's white, it's all I have. There we go. In and lock it down. Now the other end of this wire goes to frog number 1. And what I'm going to use are crocodile clips, because this is a temporary installation. So if I clip this onto, spin it out to the frog, and then I'll run the wire underneath and connect it to the relay. There we go. There's my frog wired up. Now we need a track bus. So I'll introduce the DCC track and my NC power cab, and we'll use this for track power. Once again, I'll dig out some crocodile clips. So how many have I got? I've got 3 reds, not much else. Okay, greens, yellows, blacks. I've got 2 blacks. Okay, so what I'll do, I will connect the first one, blue or black, to the pin at the, which way round is it? It's the opposite way, of course. So it's going to be the lower pin, or upper in this case. Which way you connect it initially doesn't matter, because you've a 50-50 chance that you'll get it right. And I'll show you how to test that in a moment. And the red cable, whoops, stay still, I'll attach to the other side and screw it down. So I'm now going to crocodile clip this to the DCC bus. Oops, wire came out. I guess I didn't double it up. Do it a bit longer and just bend it over like so. Everything usually goes well until you bring the camera out, and then it all goes to pot. Well, such is life. So this crocodile clip is connected to one side of the DCC bus, and that will give me a connection to the DCC bus there. The other wire will go to the opposite side of the DCC bus, taking care not to introduce a short circuit. The other thing we'll need is a DCC signal onto the track, and I'm going to introduce it here. I'll use one crocodile clip on one track and a second crocodile clip on the other, and then I'll have a DCC signal. If you have a multimeter, great. Set it to the AC range if you're using DCC, and mine's auto ranging, but if you're setting a range manually, I suggest 20 volts will do it. So if I switch the DCC bus on and the servo 4R on, we should be able to see that I've got power on this, which is reading 14 and a bit volts. And if I put it onto the stock rails of the points at the bottom. I also have about 14 and a bit volts. So I've introduced a DCC signal here. Another thing you can do, if you have some LEDs lying around, is connect them to a 1K resistor and you have a quick voltage checker. So if I drop that across the track, see it's lighting, like so. And I've got a quick check that I have track voltage. And we'll rinse and repeat the wiring for frog number 2. So first of all, I want a bit of cable. And what I'm using for this cable is servo wire. We sell it by the meter in the shop, and it's great for wiring jobs. And well, I just use it all the time. It's around me, it's inexpensive, and it's flexible, which is great. So I'll just strip a bit, like so, double this one over, and drop it into the frog, which is the center contact, hopefully on the second. Let's determine that. So I'm going to move tie bar number 2, and I've determined that as switch 2 is moving relay number 2, then that must be the relay for tie bar number 2. Takes the guesswork out. Imagine wiring up a load of frogs to the wrong relays and then realising after. You've got to do it again. So just get it right one time, right first time. And this wire I'm going to take to this frog. So let's use another green crocodile clip, and we'll run it round underneath and to that frog wire.
Well, that looks easy.
So this frog is now connected. So frogs 2 and 3 are now connected to relay number 1. Now we're going to need track power again. So I'll strip some wires, and we'll take a signal from the DCC bus . I'll put the black lead in the top. The question is, can I do it without obscuring the camera? And the usual answer is no. And the red lead, I'll strip the ends off. Use whatever your favourite wire stripper of choice is. Spin them round. Double that one over, and I'll put them in the relay terminal. Screw it down. Notice I've used the same for both relays, so I've got the red on the bottom, red on the bottom. It doesn't matter which way you do it, but just do it in a consistent way until you know otherwise. I'll connect it to a crocodile clip, and I'll connect the crocodile clip to the red rail, same as that one. And I've got a black crocodile clip, which I'll connect to the black wire, and I'll run that to the black rail. Okay, let's power up. So let's see what we have now. We were switching this one with frog number 1, live and dead, and we were switching this one, hopefully, with this frog. On, off, off, hopefully on, on. It may be easier to visualize with these. I made 3 of them, so assuming I can get good track contact, you'll be able to see which frogs are live and which frogs are dead. So most annoyingly here, it's worked first go. So I'm going to have to introduce a problem to show you how to fix it. So in the configuration here where I've got straight rails and I'm selecting this, let's call it road 1, 2 and 3. Road 2 is selected and the track is live, the frog is live. If I select the next one, road 3, now this is switched. These two are dead and the track is set for this route. And if I go the other way, this frog's switching. The track is set now to turn round and exit on the left track. 1, 2, 3. So what I'm going to do now is I'm going to turn a set of these the wrong way round. Let's do the first one. Cut the DCC power. And let's see what happens. Actually, it would be easier to just swap this over here, wouldn't it? Then I can easily correct it. So if I reverse the DCC bus, all three are lit now. Now the route 3 is lit, and that road is set for straight through. Route 2 is lit, or straight across, but I've got the turnout. So you can see it's just behaving badly. So what can we do to fix that? So if we look that tie bar 1 is controlling this frog here, we need to be able to set that so that it is in fact correct when turned. So if I follow the track, yeah, I want that curved. Curved, that's good, that's all on. The frog here looks to be correctly set. So it's not that this isn't coming on or off, it's that these two are on at the same time. So these two are reversed. So if I take the track for that and reverse it, I now get track 1 on. Reversing it, I've got route 1 on, route 2 on, and route 3 on. Now I've reversed another relay and I've reversed the polarity going in. So what we can see now is if I switch, and in this case I've switched route 1, route 1 is out, route 2 is on. It all seems weird. Now I switch route 2 and that's reversed. And then I switch route 3 and they're all lit. So all I have to do is find the cables for the respective frog, reverse them. It's the same now that I've done there as moving these and swapping them over. And now I have this frog on, I should have this frog on, and I should have this frog on. In summary, what's important is the relationship between the frog and the tie bar. As long as you've got the right channel, switching the right tie bar, and at the same time that frog has been wired to the correct relay, you're almost there. The worst you'll have to do is swap a frog polarity. Track 1 is lit, track 2 is lit, and track 3 is lit for the three-way points. Now, the polarity you end up with, whether it's positive at the bottom or top, really depends on several things, including the direction the servo is mounted on the track. So if you've mounted it with the servo one way, it will move left on a command and right on another. And if it's spun the other way round, it will move right on a command and left on the other. So you're effectively reversing the movement of the tie bar. And that's an easy solution because by reversing the bus wires, you reverse the polarity and you correct for that movement. And it's all because we're using a single pole changeover switch, which in our case is a relay. It could even be a micro switch such as this. There's 3 contacts on the back, a common and then 2 switched, normally open, normally closed, just like the relay. But I think the relay is probably a little bit more elegant and it gives you a positive switch. These also can switch 10 amps, so they're good for just about anything. But if you're not sure, consult the crib sheet. I will probably tweak these instructions just before I put it on the website. I hope I managed to keep my fingers out of the way during that video, so thanks for watching and we'll see you at the next one.